Models are mechanisms for communication. This unit looks at what a model is and what the process of modeling is about. The techniques discussed here are applicable to a wide range of systems and have one thing in common. They all commonly use diagramming techniques. We shall begin our discussion by looking more deeply at what a model is and what the process of modeling is about. We shall take a brief diversion to discuss modeling languages to see why it is necessary to rigorously define a modeling technique. We then move on to the 5 diagramming techniques as stated in this slide. Modeling is about building representations of things in the real world. Models are a means of understanding the problems involved in building something. It is an aid to communication between those involved in the project, especially between the requirements analyst and a user as part of some deliverable. A model is an abstraction which allows people to concentrate on the essentials of a complex problem by keeping out non-essential details. Since there is a limit to how much a person can understand at any one time, we build models to help in activities such as the development of large software systems. Models are, in one respect, idealizations in the sense that they are less complicated than reality. They are simplifications of reality. For example, a road map is a model of a particular part of the Earth's surface. It represents the distance between and relative positions of a set of places and the routes between them. However, models are subject to change. At the very least, they require some form of testing so that a model can maintain its correspondence with reality. As towns and cities expand and contract, a roadmap must be changed to reflect the new situation. In the worst case, a change in scope necessitates a whole new model. It would be preferable to have a consistent way of representing the different models that one might want to construct. It is important to recognize that you construct models to express your understanding of a particular situation in the expectation that the model will help you pass on that understanding to others. You should favor a modeling language that is sufficiently expressive so that you can be confident that your particular take on a situation can be represented. Easy enough to use, but in such a way that its notation allows you to express what you want to say. There will necessarily be some limitations on this because models are a simplification of reality. Unambiguous so that the number of possible interpretations of your model are minimized. Note that, ideally, that number should be 1. Supported by suitable tools so that you can apply your modeling skills and not be constrained by your drawing skills. Widely used so that you can move to other problem situations without having to learn a new modeling language every time. If you leave one project team and join another that uses the same modeling language, you need only learn about the new problem situation. This advantage is amplified if you have also moved to a different company at the same time. Naturally, the team that you join will expect you to be more productive, and if you had to learn a whole new modeling language, a data flow diagram is a graphical description of the ebb and flow of data in a given context. ADFD allows you to identify the transformations that take place on data as it moves from input to output in the system. DFDs predate UML diagrams, but still have a complementary role to play in describing systems. In a data flow diagram, an external entity is a producer of information that is outside the process being modeled. A process is a transformer of information that is within the scope of the system being modeled. And the data flow is aligned with an arrowhead that indicates the direction of data flow. It is the input to or output from a given process which is associated with each arrow in a DFD. Use case models act as a discussion tool between the requirements analyst and stakeholders and offer a common language for agreeing the functions of a proposed system. The use cases for a system are a record of the intended behavior of the system that is visible to its users. The system boundary, denoted in the UML by a rectangle surrounding the use cases, is an important conceptual line that separates the system we are interested in from the rest of the world. An actor is anything outside a software system that interacts with it. The line connecting an actor figure and a use case oval indicates an association between them, which represents communication between the actor and the use case. Actors are not intended to represent a particular individual, rather, they tell us about a particular role that someone or something might adopt in order to interact with the system. Actors are groups of people who use the current system in order to do their work. If you need to include some significant information about the roles that actors play, you can do so by expanding the use case diagram in the following way. The notation used in the figure shown indicates that guest and receptionist are specializations of reserver, or reserver is a generalization of guest and receptionist. That is, a guest or a receptionist can do the same thing as a reserver, but they can do other things as well. In situations where two or more actors are associated with a use case, one of them must initiate the actions. The other actors will play a passive role. You can use an actor to represent an external software system. The purpose of a use case is to meet the goal of its associated actor. This implies that a use case should include everything that must be done to meet that goal. The description of a use case expresses what the system should do, without constraining how it should do it. While the structure and format of a use case description may vary among the different development processes, we suggest that you include the following items as minimum details. A unique identifier for the use case that allows traceability throughout development. The name of the actor that initiates the use case, as well as the identity of any other actors that may be associated with the main success scenario. There is also the advantage of describing a use case in terms of a precondition and a postcondition, is that when you go on to elaborate the use case in more detail, that is, to describe its components, do you know that the components must also satisfy these same conditions? Precondition defines all the conditions that must be true to meaningfully cause the initiation of the use case. The postconditions section describes what the change in state of the system will be after the use case completes. Postconditions are guaranteed to be true when the use case ends. There are two situations when you would consider adding details to a use case diagram. One is to identify a common task and its associated scenarios that is shared between two or more use cases. And second is to record any alternatives or additions to the main success scenario as separate use cases. In both situations, the new tasks are shown as new use cases, and the UML provides a suitable notation, known as a stereotype, to represent the relationship between the original use cases and the new ones. Stereotype, denoted by the angle brackets, is a way of adding detail to any part or element of a model. It is a way of expressing variation or a usage distinction that tells you more about the original element. For example, the line drawn between an actor and a use case indicates that there is an association between them. We could add the stereotype communication to such a line to emphasize the communication that takes place between the two. In practice, this stereotype is left out because it is the only type of association between an actor and a use case. The main disadvantage of this approach is the additional complexity they bring to a model, in contrast to the simple use cases considered previously.